Hello guys, welcome back to another tutorial. Hit the bell icon button so that you don't miss out any tutorial.
Okay, in this video, we're going to assess the performance of our decision tree. So let's just talk about assessing model performance. And we can do this really the same way that we looked at our previous models, where we'll run a prediction here on the test data that we had held out and just compare that against the actual. So let's create something called reg tree predict. And so that'll simply be predict the reg tree mod using new data equal to test. All right, so we'll go ahead and run that. And so we get that prediction. So it's just a vector of predicted values, and then we can calculate RMSE. Recall that the caret package has that built-in RMSE function. So reg tree predict and test and target death rate. So that we see the RMSE there is about 25.34. So it's in this similar ballpark. I don't recall exactly what the k nearest neighbors was, but it was somewhere around in the 20s, right? So let's take a look here. This will be really interesting. I think this will help us understand what's actually happening with a decision tree, especially when it comes to prediction. So let's go ahead and plot the reg tree prediction against test and target death rate. Okay, test and let's see. Okay, we had a little typo there. Okay, perfect. All right, now look at this plot. This looks really odd. You'll notice it looks like we just have 3 lines of dots in the plot. And so let's just orient ourselves to the graph here. On the horizontal axis, we have the actuals. So this is the test data target death rate. And on the vertical axis is the predictions from our decision tree model. So looking at this graph, we have target death rates that span the whole spectrum, right? So we have, from say 50 or 75 or whatever this value is, all the way up to nearly 300. But on our prediction, we only have, it looks like 3 values. There's values here at 170. There's values here at about 174, 173, and then there's values here at about 200, or maybe a little above 200. So what's going on here? Well, let's go back to the plot of the actual decision tree, right? And so what we see here is we have these 3 nodes at the bottom. Okay. And if you remember, we discussed that these nodes give us a count of observations. So this node has 1,521 observations. This one has 286. This one has 631. And then it also gives us the mean of the response for all of those observations. So for example, the 170 here represents 170 is the average target death rate across these 1,521 observations. 174 here is the average target death rate across these 286 observations. And then the 201 here is the average target death rate across these 631 observations. So essentially what has happened is in our decision tree, we've ended up with these nodes at the bottom, which are called leaf nodes. These leaf nodes represent the final partitions in the sample space from our model. So this model has partitioned our sample space into 3 subsections, right? 3 subsections. And so if we were to plot the log of median income against the incidence rate, we would see that that partition, the tree has partitioned that space, that 2-dimensional plane, into 3 sections. One is simply when log median income is greater than 11. The other is when log median income is less than 11, but then it splits on incidence rate. Okay, so you could plot that out. But we have 3 sections here in our sample space. And so what the model is going to do whenever it creates a prediction is it simply takes the observation and says which one of these leaf nodes does the observation belong to. Does it have log median income greater than or equal to 11? Yes. If yes, then the prediction is 170. It just takes the average. Does the new observation have log median income greater than or equal to 11? No. Then it tests incidence rate. Is incidence rate less than 423? Yes. Then the estimate is 174. If not, the estimate is 201. So there's only 3 possible values to predict here. In other words, our model is only going to return 3 values for the predicted values. So that's why, as I mentioned earlier, the model here in this particular case with just a few predictors really is not robust enough to get us a good estimate. What we really want is a mix of sample size and variables that allow us to get more nodes or more leaf nodes in the model. So we want to have more partitions in the data set for the number of variables so that we can get more granular estimates. Because taking 2,500 observations or whatever the number is and only having 3 possible values in a regression context is kind of silly. So that's how we end up with this estimate, where we have actuals that range a broad array of numbers, but in our predictions, before we ever see the test data to make a prediction on, we know that we only have 3 possible values to actually offer for a prediction on those new observations. So again, the model handcuffs us a little bit in terms of prediction. So that's why we get this RMSE of 25. Again, it's in the 20s. I think the K-nearest neighbors was in the 20s, but I don't remember exactly what it was, but I'm positive that it was less than 25. Again, just because we see this oddity here. So that's an important thing to keep in mind whenever you're working with decision trees, particularly regression trees, is how much data do you have, how many variables do you have, and when you look at your model, how many leaf nodes are there? How many leaf nodes are there? So a naive decision tree would be just a single node, and you can only ever offer one prediction. It's the total average. But again, you want to break down more than that. You want to try to get a good mix of leaf nodes. So that's part of the process of building a decision tree model is you want to have enough, but you don't want to have so many that you're overfitting. So that's the other side of it. But that's the main consideration you're going to make, and that goes along with the idea of the complexity parameter that we talked about in the last video. You're kind of making this trade-off about how complex you want your tree to become without actually overfitting. And so that's the work you have to do as the data scientist whenever you're working with decision trees. All right, that's going to do it for assessing the model here. In the next video, we'll talk about comparing all 3 of our regression models kind of in summary, our multivariate regression, the linear model, the K-nearest neighbors, and the decision tree. We'll kind of look at the output and the performance for each of those all together and just kind of summarize the performance of each of those models. And then you'll have a chance to work a little bit on this on your own.
Thank you for watching. Don't forget to subscribe to the channel. If you like the video, do give us a thumbs up and share it. Also check out amazing discounts and offers on our premium courses in the description below.